So we like to look at the quadrilateral ABCD, and we want to have two pairs of congruent size. Then in that case, we like to show that the quadrilateral ABCD is a parallelogram. So let's try to look at this one together. So how are we going to start it? First, it would be nice if we can draw a diagonal from A to C. Once you have done that, what we get to realize is this. Since AB is congruent to CD, and AD is also congruent to BC, then we get to realize that these two triangles are almost congruent to each other between triangle ABC versus ADC. Now next, another thing which we get to realize is the diagonal AC in fact can be reflexive. So therefore these two triangles must be congruent to each other by SSS. SSS here. Now, once that happens, by corresponding parts of the congruent triangles being congruent, we get to realize angle BAC must be congruent to DCA. But in fact, these two angles are the alternate interior angles between the line AB and DC. Since the alternate interior angles are congruent, these two lines must be parallel. Likewise, angle DAC must be congruent to angle BCA. This tells us that once again another pair of alternate interior angles are congruent between the line AD and BC. That makes this line parallel to this line. Then we get to realize that we have a quadrilateral where opposite sides are parallel to each other. By the definition of a parallelogram, then this quadrilateral must be a parallelogram. So let's try to write this one up together. So here we have statement, and let's write down the reasonings right over here. So first, in quadrilateral ABCD, we get to realize AB is congruent to CD. In fact, we didn't get to write it up here due to font, but that's basically how we can write it up on our proofs. And also, AD is congruent to BC. And then the reasoning will be the given. Now, number 2. As we have seen, the line segment AC is congruent to line segment AC by reflexive property. Now, then we get to realize these two triangles must be congruent to each other. So triangle ABC is congruent to triangle CDA by SSS. Now, after showing that these two triangles are congruent, we get to realize that angle BAC is congruent to angle DCA. And then the reasoning would have been corresponding parts between congruent triangles must be congruent. Now, just to write in a simpler manner, we're just going to write down CP, CT, C. Corresponding parts in congruent triangles are congruent. Now, this tells us that line AB or line segment AB must be parallel to line segment CD. Why? When alternate interior angles when they are congruent, the line or line segment must be parallel. All right, now let us continue. Step number 6. Similarly, angle DAC must be congruent to angle BCA. Now, same reasoning, CP, CTC. Then statement number 7, we can say that the other pair, so line segment AD, must be parallel to line segment CB. Same reasoning as 5. So I'm just going to write down same as 5. Now, then finally we can say ABCD must be a parallelogram. Why? By the definition of a parallelogram. All right, that's it.